So here, put a box around this formula. This is a formula for borrowing money. PV is the present value of the loan. R is how much your payments are that you're making. N is the number of payments. And I is the interest rate per compounding period, just like before. So when we go to our example 2, person's buying a car. They're borrowing $15,000 to buy a car. Again, I'll write out the formula. So we've got present value equals R square bracket 1 minus 1 plus I to the negative n, all divided by I. And so we have to put the values in. So the present value is $15,000. And you can afford to pay $300 a month. 1 minus 1 plus. The interest rate is 6%, so 0.06. Compounded monthly divided by 12. So once again, here is our power. That is what we want to use our algebra to get by itself. So the first thing we're going to do is get rid of that fraction, so multiply both sides by 0.06 over 12. That gives us 75 equals 300 square bracket 1 minus 1 plus 0.06 divided by 12 to the negative n. Next, we'll divide both sides by 300. And now we wouldn't need the square brackets. Oops. If I subtract 1 on both sides, this negative would still be there. We don't have the power all by itself yet. We still have that negative on both sides. So in order to get rid of that negative, I need to multiply both sides by a -1. And now I was able to isolate the power. Now we can use our log laws, take the log of both sides. When I take the log of the right-hand side, that power can come out in front. And so in order to get n by itself, I need to divide by negative log 1 plus 0.06 divided by 12. Again, type this into my calculator. You should practice typing this into your calculator to see if you get the same answer. $57.68 57.68 times 300 is $17,304. How much was the car originally? $15,000. This is where interest rates become very important for understanding what you're doing. Okay? So in the end, you're going to pay $17,304 for the car. It's costing you an extra $2,304 because you don't have the money right now. This is how banks and people that lend money, this is how they make money, because they charge you an interest rate. So now on our calculator program to do the same question, okay, we don't know how many payments, so I'll just put that as 0 right now. Interest rate was 6%. The present value, they're giving you the car. They're giving you something that they say is worth $15,000. So the present value is a positive number because you're getting that $15,000. Your payments are going to be a negative $300, and in the future, you don't want to owe any money anymore. Payments are monthly, compounded monthly. We can now go up to n and go alpha solve, and we get that same number, 57.68. You hit the alpha button and then enter, because above the enter button it says solve. So now why this is fascinating and why this is important is I really, really want to show you the effects of interest rates. Okay? So here's this car. This car was $15,000. They're offering 6% interest rate. You go to another car company, they have the exact same car, but their car is more expensive. Their car is another $500 more. Okay? So now it costs more, but their interest rate is 4%. Which one should you buy? Well, if we go alpha solve on this one, you're going to pay for this car quicker. It's only going to take you 56.79 payments. If I see how much that is, 300 times 56.797, it's $17,039. So that interest rate being lower, in the end, you're going to pay less for that car that was more expensive because of that interest rate. Now, interest rates for cars, they make a little bit of a difference, right? You pay $2,000. $2,000, right? If I said first person puts up their hand gets $2,000, like you'd be like, whoa, that's a lot of money, okay? But $2,000 isn't a lot of money when you think about purchasing something bigger, okay? A car is a big purchase, but one of the biggest purchases that most people make in their lifetime is buying a house. So now we're going to look at similar things for buying a house. Now when you buy a house, a mortgage happens over 25 years. So 25 years times 12, you make 300 payments for an average house to buy it. So let's say you're looking at an interest rate of 4%. An average house right now in Winnipeg, depending on the size, depending on the location, but it, maybe a starter house, you might be looking at $300,000 to buy a house. So if I put in that the bank is giving you the house, so they're basically giving you $300,000, what this program can do is it can calculate how much you're going to pay per month. Now there's a rule in Canada that mortgages can only compound twice a year. But like we saw before, the compounding period makes a little bit of a difference, but not a huge difference. So you want to buy a $300,000 house, 4% interest rate, okay? Alpha solve. Your monthly payments are going to be $1,578.06. If we take that amount and say, well, how much do you pay for that house in total? Times 300. That house that was $300,000, when you're done paying for it, you will have paid $473,000. You would have paid an extra $173,000. You know when I said the $2,000 isn't very much? This is where things get to be big. You're going to pay an extra $173,000 to to the bank. That's a lot of extra money. Now, the good thing about a house is that in 25 years, your house will be worth more than it is. It's an asset that appreciates. As opposed to your car, in 25 years, how much is your car going to be worth? Next to nothing. It's an asset that depreciates. So buying a house, most people say, yeah, I may have spent $470,000, but in 25 years, I'm hoping it's worth that much. But you don't know for sure. Now, this is where I want you to understand the power of an interest rate. If you can work really hard, let's say you're going to buy a house, and you decide to spend an entire day phoning and researching and seeing where I can get the best interest rate, get banks to compete against each other, which bank can offer me the best interest rate, and you manage to save 0.5%. Now, most people go like, ooh, 0.5%. A half isn't very much. But let's see what difference this makes. So at 4%, you paid $473,000. At 3.5%, so we can go alpha solve, now you're paying $1,497 a month. If we times that by 300, $450 or $449. That's $24,000 less. Was that one day of working hard to get 0.5% less worth it? Right? If someone offered you a job that you'd have to work hard for one day and they said, we'll pay you $24,000, do you think that would be worth it? I'd probably work pretty hard that day. And so if you understand how interest rates work, you can save a lot of money. Me being a math teacher, I feel like compared to the average person, I've probably saved $50,000 at least just knowing how the math works and knowing what I can do with the math. Okay? I'll show you a couple things. First of all, I got really, really lucky with my first house that interest rates were really low, and I was able to negotiate it down to 1.9%. So now if we look at the same house, how much does that make of a difference? Now my payments are $1,255 times 300. That's $100,000 less than the 4% one. That's a huge amount of money that you could save. Okay? Now another thing that happens when you buy a house is most people buy a house. So let's say we're back to 3.5%, right? And your monthly payments are at $1,497. Most people, when they buy their house, they're at the beginning of their job. It's when you're making the least amount of money in your career. Because most careers, once you start them, you naturally get raises as you go along. And so you're making the least amount of money. And so the $1,500 a month is probably the most you could afford. But then, the next year you make a little bit more money, next year you make a little bit more money. What do you do? So here's two choices. One choice, which a lot of people choose, it's perfectly fine. You're making more money. You're like, we're going to go out for supper more. We're going to spend more money. We're going to go to the movies more. I'm going to buy new shoes every week. Whatever you decide. Some people decide to spend more money. But if instead you said, I'm making more money now, and instead of $1,500 a month, I could afford $2,000 a month. So you increase your payment. If you increased your payment to $2,000 a month, you don't have to make as many payments. You pay it off quicker. If I go alpha solve here, instead of 300 payments, it now only takes me 197 payments. What did that extra $500 a month save me? So a reminder, at 3.5%, this house cost us $450,000 if we stayed at 1,500. But now, oh no, I forgot the multiplication. Okay, so there, increase your payments to 2,000. The interest rate didn't change, but you decided to put more money against your house. The earlier you put more money against your house, that extra $600 a month will save you $56,000. That's a lot of money. Because that money is not only working to pay off your house, it's saving you interest that you're paying towards the bank. So every little thing that you do when you have a large debt is going to save you money, and a lot of money over time. The other thing about increasing your payments, now not only do you save another $50,000, but you're done paying for your house after 197 payments instead of 300. 100 payments is like 8 years. So that means you're going to have 8 years where you don't have to spend an extra $2,000 a month. And then you can buy new shoes every week maybe. So it all depends. When do you want your new shoes? And how do you want them? You want them right away? Then you might be paying more for your house longer. But if you're willing to sacrifice new shoes earlier and put more money against your debt, then you can save a lot of money. Now, it's really fascinating how interest rates work. Okay, right now the Bank of Canada interest rate I think is at 3.5 or 3.9, somewhere around there, and mortgage rates are similar to that, around 3 or 4%. But I want you to go and ask your grandparents, ask your parents, do they remember the lowest interest rate they ever had for their house and the highest interest rate they ever had? Now in Canada, the highest the highest interest rates that happened, I think, in the 1980s. And they went up as high as 18%. Now 18% is crazy, because let's look at this same house. You want to buy this same house at 18%. Okay? Instead of your $2,000 payments, now your payments per month are $4,400 for the same house. How much does this house cost you then? If you pay $4,400 300 times? $1.3 million. So in the 1980s, a lot of people sold their houses because they could not afford to buy them. It didn't make sense. Now, a $300,000 house in the 1980s is a really, really, really nice house compared to now. But it just didn't make sense at that high interest rate. If you couldn't buy the house, if you didn't have the money, you would pay too much in interest to get that house. So when you are making decisions for buying a house, you can find programs online that do these same things. Okay, you've got your graphing calculator. If you still remember how to use it, you can use that. But there's places where you can plug in these numbers and alter the interest rate, and you can see the effect of it. And if you understand how it works and are willing to play around with it, you can find out you can save lots of money just finding that small interest rate change. And you have to make some decisions, and with those decisions, you have to do some math with those too. But they can save a lot of money over time. Okay, so the questions with this formula are 7 and 12.